This video on First Updates Now is made possible by viewers like you and also the following sponsors. SOLIDWORKS is free for first teams. Over 80% of US engineering schools and 370,000 plus companies use SOLIDWORKS to design great products. SOLIDWORKS can help you design a great robot on desktop or on the cloud. Go to solidworks.com/first to register your team. FRC Premiere Night is back on Saturday, February 25th. Submit a unique video showcasing your team's charged up robot progress by Thursday, February 23rd at firstupdatesnow/premiere23. Premiere Night is a great way to engage with the community. Get more information and submit your video at firstupdatesnow.com/premiere23. And welcome into the Open Alliance Show, team number 599, coming in from California. Guys, thank you so much for taking the time. We got lots to talk about with your team, design process, your intake, your assembled intake. So excited to talk about that, some programming and future plans. So guys, why don't you introduce yourselves and tell us what you do on the team before we get started.
My name is Dio Padilla, and I'm the programming lead on the team. I've been on this team for about 2 years now, and I'm really happy to be on the show with you guys.
My name is Benjamin San. I'm the CAD lead on this team. I've been on the team for 2 years and I'm a sophomore.
I'm Sean Sarvasi. I'm the chief engineer, and I've been on this team for 3 years, and I'm a senior.
My name is Conrad. I'm a senior. I'm on fabrication, but I also see a lot of deadline stuff, and I've been doing FRC for like 5 or 6 years, and yeah.
I'm William Zhang. I'm the electronics and pneumatics lead for our team, and I've been on the team for about 2 years now.
So guys, I mentioned lots to cover for your team. Why don't we hop in and take a look at some of your CAD and your design process and walk us through what you've been working on.
All right.
So this is the CAD of our entire bot. As you can see, our main manipulator is the double jointed arm inspired by 971's 2018 arm. And both stages are powered by two Neos on a 160-to-1 gearbox reduction.
Our wrist for the intake is powered by a single Neo on a 80-to-1 gear reduction, and all of the gears are inside that the gearbox running along the rails in the middle. The first stage of the arm is powered by chain. The second stage of the arm and the wrist are both powered by cable. And if you go to the next picture, this is our drivetrain, which is pretty simple. It's just a 28 by 28 base with 4 Mark IVs running Falcons, and we decided to put our rails over the top. After last year on our last bot, we put the rails inside the robot, but we had a lot of issues fitting in electronics. So after we saw Code Orange's fun video, we decided to put our rails over the top. That way we have more space in the bottom to do an inverted belly pan.
So this is our arm assembly detail. Basically, as you can see, the first arm is made of two 2x1 tubes, and this is 1/8 wall, so it'd be more stiff. And then the second arm is made out of 2-inch diameter 1/16 wall round tube, and we're going to weld this into the end caps at the top and bottom.
And here's like a closer look on the top joint and the wrist. So both of them are running with cable, with the top joint running on 5/16 thick steel cable, and the bottom joint running on 332-inch cable. Here's a close look at the gearbox. So on the right side, we have the gearbox for the second stage of the arm, and on the left side, we have the gearbox for the first stage of the arm. And then the Neo more at the bottom is powering the wrist. And we tried to make this as compact as possible, trying to put in everything into one place. That way we wouldn't have to have a mess of gears all around the robot and keep our center of gravity in the middle. And here is a closer look at our braking system. So when we realized that our arm would flop around when powered off, we decided to look at 971's design again and saw that they used a pancake cylinder to push a brake into the system. So we decided to run a gear that's pushing a pancake cylinder that pushes a rotating disc that's connected to the whole gearbox, and it pushes it against a brake pad, which will stop the arm whenever we need it to.
Greg, looking at this robot as a whole here, what kind of pops into your head when you're looking at their design overall?
I mean, it looks a lot like 971, which was a great arm. So you guys did a good inspired design on that. So with the cable system, do you have independent control over every individual joint through the whole for the whole arm, or any of those like virtual four-bar to each other?
The plan is for them to have independent control, but one of our mentors said that the way we've implemented it, whenever we move the arm, the cable acts as a virtual four-bar to the bottom of the gearbox. So if we move the first stage, say the second stage would maintain its angle relative to the ground.
Okay, so your wrist is going to basically is going to rotate, kind of stay horizontal, which might be advantageous this year, right? And then with your brake in that gearbox, so you use that brake, and that brakes all the joints through the whole system, or is that just locking on one of the arms?
We have 2 brakes in there, and one for each stage. We don't have a brake for the wrist though.
Got it. Cool. Well, I mean, it looks super solid. Has your team done much welding before?
We used to do welding like 5 or 6 years ago, but we haven't done. This is the first year we've done welding since then.
It's kind of funny, Tyler and I kind of joke about this a lot, that how things have like come and changed and then gone back, and how technology in first is kind of a cycle where it's like for a long time people were building stuff out of tubes, and then tubes all went away and it became all sheet metal, and then sheet metal went away and it became a lot of welded, and now we're back to tubes again.
Yep.
But so it's interesting to see welding as a part of your process.
But when is 80/20 making a comeback, Greg?
Never.
All right. For sure. So you guys, let's go into, I know you have an assembled intake that you want to show off on there. So I'd love to see what you have for that, and talk to us a little bit more about that process, getting it to an assembly stage, and what's been working, what hasn't been working for your team so far for this.
So this is our assembled intake. It doesn't work perfectly, as we were trying to actuate earlier, but didn't. And we don't have the right wheels for it. We were planning to use 4-inch compliant wheels, but this is all we could find, just the blue ones. So we designed it so when it's open like this, it can take in cubes. It's designed to intake cubes when it's open and spit out cubes whenever needed. And when it's closed, it's designed to take in the cones, just like this. And we're able, for the cones, we want to be able to just clamp and pick up, because for the cubes we realized that on the nodes we could just spit them out and they'd probably land in the right spot. But when you put a cone on top of the node, if we spit it out, there's a chance, in our prototype we found that there's a chance that it'll come off the pole. So we decided to be able to just drop it straight down.
Got it. So just to clarify that, so your plan is you're gonna reverse the intake for the actual cubes, right? So you're gonna kind of spit them out with a little bit of forward velocity. But for the cones, you didn't want to spit them out. You just want to like release. So you have your intake is kind of multiple compound, right? So you got a pneumatic gripper and a roller wheels in the same mechanism, right?
Yep.
Yeah. So as a driver, I can open up the intake, can just drop it on the node instead of having to line it up and then shoot it out, which can lead to discrepancies in terms of accuracy.
For you guys, from a driver's perspective, even with program being integrated to this, have you looked at like anything in regards to like detecting, like, is it a cube or a cone, and that like automatically makes your claw open and close at all? Have you looked at doing anything like that?
So on our claw in here, we have a color sensor. That's gonna be right here. So when an object comes in, it knows if it's a cone or a cube and knows to spin or close.
Oh man, when they come up with purple cones later on, Greg, I don't know if they released that update yet, but that might be
Yeah,
troublesome.
the
So.
championship purple cone update, that's going to mess you guys up a little bit, maybe.
Something like that.
Very cool. So you guys mentioned as well too with Swerve for your team. How has the programming aspect been so far? Have you been able to do any testing yet, or where are you at even from assembly process so far? And then how does that integrate into how you're trying to program it?
This is actually our second build season using Swerve. We were lucky to have a Swerve drivetrain assembled during the off season, which really helped a lot during this build season because we were able to hammer down like teleop. So this season we're mainly focusing on autonomous period, and actually working through autonomous period allows us to find out like a couple core issues with how we originally structured our teleop. I guess I didn't have like a really like solid understanding of like the FRC coordinate system. So when I originally structured the Swerve drive kinematics, I thought the going forward was increasing in the y direction, but realizing how this like just made autonomous like not work, especially using the path planning, we had to restructure the way teleop worked, which took a little bit, but we were eventually able to make it work. And now we have both autonomous and teleop working on really great.
Right. So last year we built an entirely new cop season robot. During the regular season, we built an every bot because we're a fairly new team. Because of COVID, we had all just basically first year members. And then during the off season, we built a flywheel bot come with Swerve, and we learned a ton from that, which is I think going to propel us forward to be able to do well this build season. And we have a lot of practice with Swerve in terms of programming and driving. And we've had a mostly assembled chassis for about a week now that I have to my right.
So what is your so having a chassis is a great resource this time of the season. What does your drive practice session look like right now? If you don't have the whole robot built, but you have to have a chassis, are there any sort of routes or anything that you're practicing specifically on?
Right. So we have an assembled 2022 bot that we've been practicing most of our Swerve on. It's just behind me. Ken's on the table over there. And most of my drive practice is more or less just practicing cycles and just getting a feel, come for the robot, because the most important way you can be a good driver is just have hours on the robot. And we're planning on doing just that. And we'll fine tune everything once we have a completed bot.
Yeah. Do you have access to a full field now, or
we have about maybe a third of a field. We have all the game elements, but we don't have a full size carpet. But we do have a pretty decent sized area.
So you should have enough, at least from programming. You should be able to get most of your real estate in for what you're looking at that side, right?
Yeah, absolutely. And we plan on going to other teams' practice fields. I think we're going to 4201 Vitruvian, 3476 Code Orange, and Circle Life.
What are some, as we look, forward once again, and we'll have your team on in a few more weeks as well too, much closer to completion. And I know you guys compete week 2 at Ventura. So, what are some future plans? What do you immediately want to get done? And looking into the next couple of weeks, where do you kind of want to be in your build season progress?
So, after looking at many build threads, we decided that we realized that our bot, we have a good core structure, but there's a lot of stuff we could add, such as a buddy climb like the wild boars are doing, and maybe a ground intake or funnel to take stuff from the human player station much easier, as well as we decided to make 3 different intakes. So this is like our first intake. We're also planning to fabricate like an every bot intake and a sushi squat type intake.
And we're gonna see which intake works best, and if they all don't work too well, we might just design a 4th intake.
Our intake design philosophy is that we designed cover the wrist first, and from there we just can design our intake to be compatible with that wrist, so we can change them out really fast.
When do you want to have that decision process made by, and what you're going to move forward with exactly?
Probably maybe a week or 2 before comp, so maybe week 1, week 0.
Awesome. Well, 599, thank you so much for telling us about your progress so far. Cool to see it, and I really like the design, so I'm really excited to see that come to fruition, especially when we have you back on next time. I'm sure we're going to see a lot of different mechanisms assembled on your robot. So, of course, follow 599 and their build blog on Chief Delphi, and, of course, on the OA Discord as well, too. But, guys, thank you so much, and good luck over the next few weeks. We'll see you soon.
Yeah,
Thank
absolutely.
you.
Thank you.
This video on First Updates Now is made possible by viewers like you and also the following sponsors. SolidWorks is free for first teams. Over 80% of US engineering schools and 370,000 plus companies use SolidWorks to design great products. SolidWorks can help you design a great robot on desktop or on the cloud. Go to solidworks.com/first to register your team. FRC Premiere Night is back on Saturday, February 25th. Submit a unique video showcasing your team's charged up robot progress by Thursday, February 23rd at First Updates Now/Premiere23. Premiere Night is a great way to engage with the community. Get more information and submit your video at firstupdatesnow.com/Premiere23. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.